Hey, Mr. P here. In the last video, we talked specifically about structure and function of hairs. So we talked about the anatomy or the anatomical structures within a hair. We talked a little bit about differences between different groups of people and different locations of hair. And in this video, we're going to dive in a little deeper, and we're going to look specifically about kind of the analysis around how we can use hair to help better our situation within forensic science and within a crime scene investigation. So, hair analysis, buckle up, let's go. So, the first thing that you have to be familiar with is what a typical hair sample consists of. And it's really important due to the inconsistencies among hairs that we talked about in the previous video, in that the medulla type could fluctuate between different locations on the body. The thickness could fluctuate a little bit. There's just natural variations among hairs, and so to kind of combat the inconsistencies and the variations, we want to collect a 50 hair sample of a suspect or victim's head in order to analyze and then average the value in order to kind of make a more comfortable prediction or a more comfortable match about the physical descriptors of that particular person. It's just like in any scientific experiment. You want to maximize the number of trials, you want to maximize the number of replicates in order to make valid and strong detailed conclusions. So there is natural inconsistency and natural variation among hairs. We want to always collect a minimum of 50 hairs as a sample so that we can kind of characterize and eventually average the values of that particular individual so that we get a more legit, valid, detailed result. So, hair life cycle. So let's look at what a hair typically does from kind of, let's say, birth to death. Now, I know hairs aren't living and they're not born or die, but from start to finish, the hair goes through a very descriptive, specific order of events in order to kind of produce the hair in its current form. So, the first phase of the hair life cycle, which is the anagen phase. Okay, anagen phase. It's the growing phase. It's the phase in which the hair grows. It lasts for about 1,000 days. Okay, which is obviously several years because a year is 365 days. So this phase lasts several years. It is the first phase of the hair life cycle. It accounts for 80 to 90% of all hairs on the body because of the sheer length that phase kind of lives in. Right? If a phase lasts that long, then it's really easy to conceive or really easy to believe that 80 to 90% of all hairs are going to belong to that particular phase. Cells around the follicle in the anagen phase are rapidly dividing and depositing materials within the hair. That's what actively grows the hair shaft. The blood supply is good, the nerve endings are good, the nutrients are dense, the cells are rapidly dividing, they're producing the keratin and the protein that the hair needs in order to be produced, and so the hair is rapidly growing within those 1,000 days. Now, we transition to the second phase, that is the catagen phase. The catagen phase is the transition phase, so the hair stops growing, the follicle recedes. You'll notice that the follicle, kind of this really light border, which is up really tight to the hair shaft, actually recedes out. So this follicle kind of pulls back. The blood supply is reduced. Okay, everything kind of recedes from the hair. The hair is still firmly planted in the skin, but everything does recede a little bit. So this accounts for about 2% of all hair growth and development in this transition or this catagen phase. The telogen phase is kind of the dormancy or the resting phase and or the shedding phase. And so the follicle is dormant. You can see that the follicle completely recedes. It goes into a state of dormancy or resting. Hairs are easily lost or shed because they're not kind of readily held in place anymore. Nothing is really holding it tight, and so this is how animals readily shed. This is why your dog or your cat or even you lose hairs periodically all the time, right? Because they're easily lost or shed in this phase. This is about 10 to 18% of all hairs on your head or on your body, for instance, are within this this phase, and so it makes it easy when you're looking at the sheer number of hairs on a dog or a cat, for instance, that 10 to 18% of the hairs is quite a few hairs, which is why they shed and why they deposit hair in your house. At the end of the telogen phase, the blood supply reconnects. You'll notice that the blood supply is reconnecting to the new follicle once the hair is shed. And once the blood supply is reconnected, the follicle kind of holds up tight and it actually starts producing a new hair. So reconnects to the follicle and another anagen phase begins. So here's early anagen phase. The new hair is just protruding beyond the skin, and it will persist or last for the next 1,000 days, in which this hair kind of grows before it is kind of stopped. It transitions into that telogen phase again and will be shed or lost. And so we are constantly producing new hairs. We're constantly shedding off old hairs, and that's just one way the body kind of helps maintain good quality hairs to protect it from its environment. So what about treated hair? It is not unlikely for somebody to treat their hair. They can dye it, they can bleach it, they can do a variety of different things which treats it in a variety of ways. And so we're going to talk about that. One of the main ways that hair can be treated is bleaching. And bleaching is oxidizing the natural pigment, which makes it lighter, but it also makes it more brittle, and it disrupts the scales on the surface, which is called the cuticle. If you remember from last video, they're like those shingles that overlay from scalp to tip. The oxidizing agent of bleach can actually disrupt the surface layer, okay, which can produce a lighter pigmented but also a more brittle, less sensitive hair. Artificial bleaching leaves a sharp demarcation along the hair, while bleaching from the sun leaves a more gradual mark. The sun does bleach hair. Okay, if you spend a lot of time in the sun, it actually can lighten your hair. You probably know that. Artificially bleaching can actually leave a really, really sharp demarcation, which you can kind of see when you look at a bleached hair, or when you look at an artificially bleached hair under a microscope. You'll actually see that the outside appears to be essentially transparent or translucent, more so than it is on a non-bleached hair. And that's what we call this demarcation, which kind of is indicative of that artificial bleaching. Okay, peroxide in bleach can also damage mitochondrial DNA, which doesn't do anything for you other than the fact that it does kind of damage any mitochondrial DNA that can or could be recovered from the hair that was potentially left at a crime scene. Dyeing hair changes the color of the hair shaft and gives it a painted appearance, which can be seen over here. Okay, notice that these are all different colors. They're kind of uniform throughout. It almost looks like they're artificially colored, because they are, and they look more like artificially synthesized fibers as opposed to normal, naturally occurring hairs. So the cuticle and cortex both take on the color of the dye, because that's what the dye is being used for. It's being used to artificially color. So bleaching actually pulls color out, while dyeing actually puts color in, which is why you don't see this demarcation or these kind of translucent borders on a dyed hair like you do a bleached hair. Getting into ethnic or ancestral differences, when you look at different ethnic individuals, or individuals within different ethnic or ethnicities or ancestral backgrounds, it is really easy to notice some key differences between hairs. And again, we're looking just at head hairs right now. And so the three kind of main ethnicities or ancestral differences we're going to look at right now is Caucasian or European descent, African descent, and Asian descent. So we're looking at three groups of people, three different classes, right? If we're looking at that class evidence, the Caucasian or European descent will relate to a specific class of individuals, African a different class of individuals, and Asian a different class of individuals, based on some key or specific characteristics, which we're going to get to in a minute. Okay. In Caucasian or European descent, you will notice that the color of those varies quite a bit. It can actually vary from blonde to red, brown, and black, and they can be different variations of those colors. You could be really, really light blonde to kind of dark blonde, kind of mousy blonde, to really light brown, to medium brown, dark brown, and then ultimately to black. Right? That's a very large, wide, encompassing variation among the colors, which is unique to this class. Small and evenly distributed pigment granules. So you'll see that the pigment granules are evenly distributed throughout, and there are very small, typically very small numbers of those pigments, which is what's keeping the hair lighter in comparison to some of the other descents that we'll talk about. The cross-section of the hair, again, we're looking at a cross-section, so we're looking at kind of the diameter and the shape, like we talked about in our last video. But in Caucasian or European descent, the cross-sections often have minimal variation, but they can be oval or round, depending on the shape or the type of hair, whether it's round, whether it's curly, whether it's wavy, or whether it's straight. As you compare that to the African descent, when you look at it just based on these pictures, you notice that the pigments are densely distributed throughout and clumped together. And they may differ in size and shape, but there isn't as much variation among color as there is in the Caucasian or European descent, because most 99% of the colors of hairs within individuals of this African descent, because of the densely distributed clumped pigment granules, the hair is really dark black. When you compare the cross-section of this group of people to the Caucasian and European descent, you'll notice that they are very flattened, and they have small diameter, they're very thin, and they have a lot of variation, but they are more oblong, they are thinner, they are little, and because of this, the hair is typically a lot curlier and tighter in the curls than the curls associated with the Caucasian or European descent. As you compare both of those to the Asian descent, you will notice that the hairs in an Asian descent are also densely distributed, and so they are very darkly or dark colored as well. They also tend to be very coarse and very straight and very thick and continuous medulla, and again black color. And the black color comes from the densely distributed pigment granules. But when you look at the cross-section of individuals with the Asian descent, you'll notice that they are very round, they have very large diameters, they are very big, coarse, thick hairs, and because of that, they are very, very straight. Okay? The more circular a hair cross-section, the straighter the hair is on the head, right? And so the more flattened and the smaller diameter a hair is, the more curly it is, and the more tightly packed it is on the head. Okay, so there are three different classes of individuals, and you can see that there are key differences between these different descents that is very easy to tell with general microscopy techniques. So now let's look at a difference between animal and human hair, because one of the main things of the class is that we want to be able to differentiate between animal hair and human hair, and you'll see that there are a variety of differences. We're going to look at pigmentation patterns, medullary index, and the cuticle type. And so the first thing we're going to focus on is this pigmentation pattern. These are all animal hairs, okay? And so human hair pigmentation is denser towards the cuticle. Animal hair pigmentation tends to be denser towards the medulla. You will notice that this is an animal hair because when you look at this area, okay, from the cuticle to the medulla, the pigmentation actually is kind of in a gradient towards that medulla, okay, which is different than in a human hair. So animal is going to kind of hold the pigmentation closer to the medulla than human hairs. In animal hairs, pigments are often found in solid masses called ovoid bodies, especially in dogs and cattle. Human hairs are usually one color along the length. Okay, if you compared this picture to, let's say, this one, which is a human hair, you will notice that the pigmentation is pretty uniform throughout, and in this one, the pigmentation is kind of clumped into the structures called ovoid bodies. Again, you can see the ovoid bodies here, clumped pigmentation. That is indicative, because it is not very uniform, of an animal hair, not a human hair. So this is a dog. You can see the ovoid bodies. This is a cow. You can see the ovoid bodies. The dog and cow, obviously one of the most unique in that it varies. It is much different than human hair. Okay, so going into the medullary index, which is the second difference we're going to focus on. Remember, pigmentation was that first difference where the pigmentation is either uniform in human hairs or clumped in animal hairs. The medullary index is looking at how thick the medulla is compared to other hairs. So this is a cattle hair. Okay, this is a cow. This is a human hair. You can see that the relative thickness of the overall hair is different, but you can actually see most notably that the medulla in a human hair is much, much thinner than the medulla of the cattle hair. We call that a medullary index, and we can actually put a value, or we can quantify the medulla based on this medullary index. If the medullary index is 0.5 or more, okay, 0.5 or greater, then it is an animal hair. If it is 0.33 or less, it is a human hair. Animals have bigger medullas. Humans have smaller medullas. Okay? And that's just a simple scientific fact. Right? We know that. We've done medullary index studies on different types of hairs, different animals, and we know that to be true. So, in animal hairs, the medulla is proportionally much thicker than it is in humans. Now, I know you can say that this medulla is thicker than it is in humans because the entire hair is thicker, and so naturally it should be thicker. But when you look at how much this medulla takes up of this hair, it's essentially at 50% or more, whereas in humans it's only roughly a third of the hair, which is where we get to this 0.33. This air-filled region of the hair aids in providing insulation. That's really important because humans have kind of lost the need to warm themselves like an animal that is still living in the wild and is still subjected to a lot of the conditions in their natural environment. If the medullary index is greater than 0.5, the hair came from an animal, and if the medullary index is 0.33 or less, the hair came from a human. So if you look at a hair and the medulla looks like it's about a third of the total width of the hair, then it is a human, and if it looks to be about or roughly 50% or more, then it is animal. Last difference we're going to focus on is the cuticle type. Now, when you look at this, hopefully you would know right away that this is not a human hair. This is not the way human hairs look, and this is not a human hair as well. This one is. Okay? When you look at a human hair under a microscope, you will hopefully see that we have just kind of these really small, finite scales that overlap from scalp to tip, kind of like mini shingles, which helps to secure the hair and the medulla and the cortex within. But in humans, we differ from animals, and so animals have cuticles as well, but animal cuticles vary greatly in comparison to human cuticles. So hair cuticle can also help distinguish human hairs from other animals. Different animals like a bat have different cuticle types. The bat has what we call a coronal cuticle type, and it essentially looks more like a feather where they kind of flare out a lot. Now, a mouse is also coronal, so a bat and a mouse are just both examples of animals that possess this type of scale pattern or this type of cuticle type. A mink or a cat have what we call a spinous scale pattern or a spinous cuticle type. It looks almost like a snake scales, where they are a lot more pronounced than the scales of human hair. Humans have what we call an imbricate pattern or scale pattern. And so when you look right away, if you see anything that looks kind of like snake scales, it is spinous, that is animal. If you see something that looks kind of feather-like, it is coronal, that is also animal. If you see something that looks very, very smooth, okay, virtually smooth with just a little bit of ridge detail, that's what we call imbricate, and that is the human scale pattern. Okay. And I think that's where we're going to cut it off for this video. There will be a third video that I follow up both of these two hair videos when we start getting into this actual chemical testing, first hair collection and chemical testing, DNA testing of hairs. So stay tuned. Bring your questions to class. Bye.